So previous is equal to current, and now we're gonna say current is equal to next. So we want to move this one here. Okay. Now you guys are asking like, oh, what happened to this one? Now we're gonna do one more iteration. We're gonna come back here. We haven't reached to the end of the linked list. It says n is equal to c arrow next. So this is gonna move to here. C arrow next is equal to P. C arrow next is this one is equal to P. Now this is the part that we needed. This is now gonna move to point to this one. P is equal to C. So this is this, and C is equal to N. So what we're basically doing here, we're moving C and N and P one ahead at each iteration, and we make C arrow next to point to the previous. Okay, so that's basically what's happening here. Like I'll just do one more iteration. N is equal to C arrow next, so this is gonna happen now. C arrow next is equal to P. Right? And P is equal to C. And C is equal to N. Okay? And one more time. Is C equal to null? No. N is equal to C arrow next, so this becomes null. And C arrow next equal to P, so this becomes this. P equal to C, so P becomes this pointer, C becomes null. And we are done. We reverse the linked list. This is not null anymore. We reverse the linked list. Are we done? No. One very important part is left after the loop. We still have the head pointing here. Shouldn't be pointing here anymore because this is not the head of the linked list. This one is. So what do we have to do after the loop? That's correct. H is equal to P, so that this moves to here. Okay. So I just wanted to show you that reversing a linked list is also possible. One last thing I wanted to show you. This one is a little bit, again, challenging, but let's just like see it. So we have two linked lists. Say pointer 1 is the head reference for this one. Pointer 2 is for the other one. Say this is 7, this is 13, this is 1, and these are null. Okay, what we want to do, we basically, excuse me, we want to end up with just one linked list, like the appending we did before, right? But instead of just appending this list at the end of this one, we just want to do something like this. We want to do zigzag. Right? We want this node to point here, then this node point here, this node here, here, and here. So some sort of zigzagging between two linked lists. That's a little bit challenging, okay? Again, we are gonna create two pointers, let's say current 1 and current 2. Okay. And also, because we might need we actually need the previous node as well. I'm just gonna call P previous 1 and previous 2 as well. Okay, I'm giving you the final answer, but I encourage you to do it yourself before looking at the solution. Just to figure out, like, do I actually need this one? You might just be able to do it without these extra pointers, or in many cases you might need actually another pointer as well. Like, for the example, for the reversing linked list, we had 3 pointers: current, next, and previous, right? So what we do here, we initialize C1 and C2 with the head pointer, and we say that while C1 is not equal to null, or C2 is not equal to null, right? Let's say, like, if we finish one of them first, means that there's nothing else that we do, right? So there's nothing else to add. So in this case, we say previous 1 is equal to C1, which is what we have right now. Previous 2 is equal to C2. Now we want to move the current pointers, right? So C1 is equal to C1 arrow next, and